Case history number 6 is about a multi-zone gas producer. The locations of the application are the San Alberto and San Antonio gas fields at the Tarija region in Bolivia. As usual, all the details of this case history can be found in an SPE paper co-authored with the operator. First, let's discuss the background of this installation. The initial equipment selection for this field was made in the late 1990s. And at that time, the fiber optic technologies were new to the oil and gas industry. Perhaps for that reason, the operator decided to select the electronic gauges over fiber optic gauges. 4 wells were completed with electronic gauges. Unfortunately, the results were disappointing. One of the gauges did not work, one failed at the beginning, and one failed months later. Only one gauge worked intermittently. A failure analysis was made by the operator, and the root causes were found to be high vibration, high temperature, measurement drift, which was worsened by high temperature effects, and the overall longevity issues of the electronic sensing systems. Several years later, the operator came up with a workover plan to replace electronic gauges with optical sensing technology. By then, the optical sensing technology was gaining traction and already established many advantages over the electronic sensing technologies. For example, a fiber optic gauge would have been very beneficial and advantageous on the failing points of the electronic gauges in those wells. Compared to an electronic gauge, a fiber optic gauge has a higher vibration rating by a factor of 6 to 1, a higher temperature rating by 25 degrees Celsius, and a lower measurement drift factor, 1/4 of the electronic gauges, and a longer longevity, which is 4 to 1. Once the optical monitoring system was successfully installed and the operator verified that the system is functioning properly without any issues, the operator decided to implement optical solution in all new wells. Now, let's get back to the well which was monitored by the optical systems. The well was a dual-zone, high-rate gas producer, and the installation was completed in 2011. 2 downhole, 2-phase optical flow meters and optical pressure temperature gauges were installed. Here is a schematic of the completion. There is a lower zone and an upper zone. The flow meter with the 3.5-inch size was installed between the lower zone and the upper zone. So it was measuring the lower zone flow rates directly. The second flow meter with the 4.5-inch size was installed above the upper zone. So it was measuring the commingled flow rates from both zones. The contribution rate of the upper zone is found by subtracting the lower flow meter flow rates from the upper flow meter flow rates. The optical monitoring system has proven its value to the operator on many aspects. It provided real-time flowback testing data Flowback is the first stage of production after the completion of a well, and it usually lasts 1 to 4 months. And the production fluid is a mixture of oil, water, gas, and sand. Once the flowback phase was over, the monitoring system continued to provide real-time monitoring of pressure, temperature, and flow rates. Longevity and reliability were also important factors for the operator, especially after what they have experienced with the electronic gauges. This case history demonstrates the performance and reliability differences between optical and electronic monitoring systems, because both systems have been exposed to similar downhole conditions in the same well, and yet the optical monitoring systems continue to function to date.